everyone. In this example, we're going to be determining points at which a tangent line has a specified slope. So in our first example, it says find the points on the graph of f of x equaling negative x cubed plus 6x squared at which the tangent line is horizontal. So we recall that the derivative is the slope of the tangent line to a curve. The slope of a tangent line to a curve, so that's important. And the slope of a horizontal line, we recall, is 0 from our algebra. So what we want to do is find all the points on the graph of the function where the derivative of the function equals 0. So for f of x equaling negative x to the third plus 6x squared, what we do is take the derivative. So find f prime of x. So here we can just go ahead and apply the power rule, and that's within the sum and difference rule for derivatives. So this becomes negative 3x squared, right, plus 12x. So now we'll set f prime equal to 0. So that means negative 3x squared plus 12x equals 0. And then just go ahead and solve this. It looks to me that they have a GCF in common. They have x's in common. I see that plainly. However, they also have a coefficient of 3 in common. The first term is negative, so the GCF will always be negative as well. So 3x is the GCF. It goes into 3x squared x times. Negative 3x goes into positive 12x, negative 4 times. And now we use the zero factor property, zero product property. We can say negative 3x equals 0. And we can say x minus 4 equals 0. So here, dividing both sides by 3, x equals 0. Here, adding 4 to both sides, x equals positive 4. All right, so now to find the corresponding y values for these two x values that we've found, we're going to substitute back into f of x, our original function of negative x to the third plus 6x squared, right? So we're just going to sub back into the original function. So we'll do this for both of these. So we'll sub back f of 0, and we'll sub back f of 4. So subbing 0 in everywhere we see x gets us negative 0 cubed plus 6 times 0 squared. So all of that leads to just having 0. Now f of 4, a little bit more work, negative 4 to the third plus 6 times negative 4 squared. Remember to do the correct order of operations, right? So we have all of this computed, doing the exponents first, the multiplication, doing these exponents, and then adding them together, I get 32. So therefore, that tells us the tangent line to our graph, to the graph of f of x, let's clean that up a little bit. The tangent line to f of x equals negative x to the third plus 6x squared is horizontal at the points that we just found, 0, 0, and where x was 4, the y value was 32. So this is part 2. So our second example, it says to find the points on the graph of f of x, which equals negative x to the third plus 6x squared. Okay, it's the same function, at which the tangent line this time has a slope of 6. So we're going to use the same strategy that we did in the previous example. except now we're concerned where the derivative equals 6. Okay, so remember, we already found f prime of x in the previous example, so I'll just write that over. It's negative 3x squared plus 12x. So we'll say negative 3x squared plus 12x equals 6. All right, how do we solve this? It looks to be quadratic, right? You see a 2 as the largest exponent, so this is a quadratic equation. To solve a quadratic equation, we should put it in standard form, meaning let's move that 6 over to the left side of the equal sign. So 3x squared plus 12x, and to do that, you subtract 6 from both sides. And now it's in standard form. So here it looks like we can maybe divide everything by negative 3. Divide everything by negative 3. So we get x squared minus 4x plus 2 equals 0. Doesn't look like I can factor this easily. So what we'll do is go ahead and use quadratic formula. So a is 1, b is negative 4, and c is positive 2. So plugging that into the quadratic formula. So the formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a, if you didn't remember. Negative of a negative 4 plus or minus negative 4 squared minus 4 times 1 times 2. That's all over 2 times 1. All right, so we do some number crunching and we get 4 plus or minus 16 minus 8 over 2. And then it gets us 4 plus or minus 8 over 2. That's still the square root of 8, sorry. And you have to simplify that square root of 8. So you have 4 plus or minus, the largest perfect square root that goes into 8 is 4. So that'll be the square root of 4 times the square root of 2. The square root of 4 is 2. The square root of 2 you can't break down any further. It stays underneath. And that's over 2. Right? So square root of 8 was 4 times 2. Square root of 4 times square root of 2. And that's how we get these. Right, and then we can go ahead and simplify that a little further. 2 can go into each one of those. So 2 goes into 4 twice, goes into 2 once, and you can write a 1 there or not. And it goes into the 2 in the denominator once, and we don't have to write it over 1 because we know that just means what we have here. All right, so we have 2 plus square root of 2 and 2 minus square root of 2. So these are the x values, right? These are the x values, just like in the last example. So now we substitute it into f of x. So sub back into the original function. The original function was negative x cubed plus 6x squared. So we're going to sub those into each one. Okay, so f of 2 plus square root of 2 equals negative 2 plus square root of 2, and that's to the third power, plus 6 times 2 plus square root of 2 to the second power. Okay, so what do we get here? So if we were to cube this, and you may want to refer to some shortcuts for cubing binomial and such, we'll get negative 8 plus 12 square root of 2 plus 12 plus 2 square root of 2 plus 6 times, and then we square this binomial, square the 2 plus square root of 2 before we multiply times 6. We get 4 plus 4 square root of 2 plus 2. That gets us negative 20 minus 14 square root of 2 plus 36 plus 24 square root of 2. All right, and then combining like terms, we get simply 16 plus 10 square root of 2. All right, so, and then in a similar way, if you were to do f of 2 minus square root of 2, I'm not going to show all of that in this one, but you can follow the same procedure as above, right? Just substituting this in and then cubing it and then squaring it and then multiplying times 6, combining like terms, you should get 16 minus 10 square root of 2. So the tangent line to f of x equals negative x cubed plus 6x squared has a slope of 6 at so and we'll say the tangent line has a slope of 6 at these 2 points. The first point is 2 square root of 2, comma 16 plus 10 square root of 2. And the other point is 2 minus square root of 2, comma 16 minus 10 square root of 2. So the tangent line to the function has a slope of 6 at these 2 points.